future of industrial IoT is really exciting. It looks like a platform and a capability where we can start to solve a lot of the problems that we haven't been able to in the past.
The global energy consumption is increasing by about 40%. The electric energy consumption in the world will go out by about 80% in the next 10 years. Simultaneously address the issue of energy consumption increase and reduce carbon emissions. So you have to be 300% more efficient in terms of energy automation. These kind of things will be enabled by IoT.
Our vision for IoT has a lot to do with the notion that what we call an asset control system. Control systems have traditionally been architected along the lines of the constraints of the physical devices from 30 or 40 years ago. The architecture of these systems does not match in any manner, shape, or form the physical architectures of plants. So the first step of this is that the control systems of the future, which will be IoT based, will match the physical architectures of the plants. They'll line up around measurements and then equipment and then units of operation, areas of operation, plants, fleets of plants, etc. So that the idea becomes that the system mirrors the plant and the clients will have a much better understanding of what they are seeing in the system.
So today there is a plethora of platforms out there, right? When you look at a smartphone, there used to be lots of operating systems, but there's two leading platforms, the iOS platform and the Android platform. When you look at the automotive industry, you have an IoT platform, Ford, one more from GM, one from Fiat, from Mercedes, Daimler, Chrysler, one from BMW. Same thing in the industrial IoT world, right? We have platforms from Schneider, platforms from Siemens, from GE, from Rockwell, and so on. And all these platforms cannot all coexist.
The only way you get to this type of outcome is where the actual end users drive it. And we've got great examples of that in other industries. If you look at like aerospace and defense, FACE, or the Future Airborne Capabilities Environment, created an open platform or open standard for developing next generation avionics systems. In the communications world, we had OpenNFV, where all of the carriers got together and basically defined a new topology that really leveraged open systems and kind of broke the existing kind of technology deployment into a four-level model that had great economic benefit for everybody.
We have applications for both general purpose and real-time operating systems, and frankly we have a lot of legacy in all of those carry forward. So I think we'll continue to see that mix, and really part of our challenge as we build the platform is how do we do so in an agnostic way.
The industrial IoT in the industrial sector in general, is generally a slower moving market segment. And so a transition like this, a digital transformation, is going to take a long time to play out, probably a decade or maybe even more. So we see it rolling out in different phases. And the first phase is around connecting the unconnected. There are a lot of assets out there. Estimates are up to 85% of assets being utilized today are not connected. The second phase is around making them smarter and more intelligent. And this is allowing that data to get transformed into events or into actions that are meaningful, whether that's predicting when a tool will fail or optimizing the supply chain. So that second phase is about being smarter. And the third phase is quite honestly what I think is most exciting. And it's when things become more software defined and when things become more autonomous. And this allows the industrial sector to move at the speed of software.
Data doesn't provide a value by itself. You have to extract useful information and you have to make it actionable, because without actually doing something with the data, it doesn't have a positive impact.
It's an aha we've got from some of our market research in terms of looking at industrial Ethernet infrastructure. We look at technologies like software-defined networks as being something that's in the data center, and it's going to be in the data center for years, and by the time that technology reaches the factory floor, it's going to be years and years. Not so. Clearly, we see a few products already in the market in the industrial space that are using technologies like SDN, even on very small networks, and the reason they're doing it is because it gives much more security and visibility of what's going on in the network, and these are networks for critical infrastructure.
We actually like to talk, instead of about IoT, about IoTSP. And what does that mean? Our view is that it's much more than a technical system. It's a technical system combined with a social system and combined with the people and combined with the services that will make the whole thing a success.
People think about innovation, they think first about profit motive, and that is important, obviously, but social benefit is also important. And I think if you look at things like IoT, social benefit could be huge. There's the obvious benefit in terms of the planet in general. The faster we can accelerate obsolescence of equipment and bring in new innovation, it's going to be a positive, lower power, lower waste, etc. But then think of the outcome of what we're actually implementing, lowering food cost, how we actually disperse food, improved goods and services, and just information in general that's going to help people live a healthier and happier life. That's the exciting thing right there, is how you use this innovation to really change society in general.